Good morning. This is Nas from NB Network Lessons. Hope you guys are doing okay. Before I get started today, I just want to thank you for an amazing response from all my users. Thank you so much for watching all my videos and providing feedback. That really means a lot to me. Hope you continue doing that. Thank you again. So having said that, today's topic of discussion is Kirchhoff's voltage law, which is also abbreviated as KVL. In my last section, I discussed Kirchhoff's current law, which is also abbreviated as KCL. As you recall, Kirchhoff's law applies to any node where resistors meet, like you have one resistor, two resistors, three resistors, and what Kirchhoff's law states is that sum of all the currents which meet at a node is zero. So now we're going to look at what Kirchhoff's voltage law is. So Kirchhoff's voltage law basically states that in a closed circuit, in a loop, the sum of all voltages is zero. Let's look how. So let's look at this example right here. So I have this V sub S, which is the source. Then I got R1 right here, and the voltage drop over here is V1. I have R2, and the voltage drop over here is V2. And then I have R3, and then the voltage drop over here is V3. So V1 is voltage drop right here, V2 is voltage drop right here, and V3 is voltage drop right here. So now look, let's apply Kirchhoff's voltage law and see how it plays out. Let's write down an equation. So one thing I just want to mention is that if you have a resistor, right, and current is flowing in this direction, this is going to be plus, this is going to be minus. All right. In this case, I'm starting from here, and this is a minus, so then it's going to be minus V sub S, okay, plus voltage drop right here is V1. Okay, plus voltage drop right here is V sub 2, all right, plus voltage drop right here is V sub 3 is equal to 0, all right. So that's what Kirchhoff's law states, that sum of all the voltages in a loop is 0. So what if we have two loops? Okay, so let's say we have a circuit or diagram like this. In this case, I can see that I can write down Kirchhoff's voltage law equations, but I'm going to have two. Okay, so let's look at the first loop. The one in red right here shows loop number 1. So I start from here. So I say minus V sub S plus, what is the voltage drop over here? I've got I1 current, R1 resistor, apply Ohm's law, V is equal to IR, so that's going to be I1 times R1. So that is going to be and that would be equal to 0, okay? So then I can say easily, using my algebra, V sub S is equal to I sub 1 R1. Okay, so that's my loop number 1. That's my KVL at loop 1. Now let's look at there's another loop in there. So you might guess that this is the loop right here. That's not the loop I'm talking about. I am talking about this loop right here, and I'm going to put it in green. This loop right here. Okay? So now let's write down Kirchhoff's voltage law on this. So we're starting from right here. Okay? So if you got minus V sub X, okay, right here, and then we go down, and this is the loop. So this is going to be plus, let me just make this legible, R2. So plus Current over here is I2, resistance over here is R2, apply Ohm's law. So then we're going to have I2 times R2 is equal to 0, and I can simplify this, and V sub S is equal to I2 times R2. So that is basically Kirchhoff's law right there. If you have more than 2 loops, okay, you can use that also, okay. So when you get into solving equations, when you get into solving problems where you have number of components, some in series, some in parallel, then you will apply KCL also and KVL also to determine what the voltage at a given point is, or what a current is at a particular node, what current is flowing through, and so forth. So hope this helped you. I'm going to come back in my next lecture and do an example, solve an example for you. Hope you liked it. If you do like it, go ahead and share. Please share it as much as you can. Thank you, and go ahead and give me a like if you like the video. Thank you so much.